Hello, and welcome to Two Think Minimum, the podcast of the Technology Policy Institute. Today is Monday, October 31st. I'm Scott Walston, president of TPI, and I'm here with my co-host, TPI Senior Fellow, Sarah O. Lamb. And today we're delighted to have with us Avi Goldfarb. Avi is the Rotman Chair in Artificial Intelligence and Healthcare and a professor of marketing at the Rotman School of Management at the University of Toronto. He's also chief data scientist at the Creative Destruction Lab, a faculty affiliate at the Vector Institute and the Schwartz-Reisman Institute for Technology and Society, and a research associate at the National Bureau of Economic Research. Avi's research focuses on the opportunities and challenges of the digital economy. Additionally, he is co-author, along with Ajay Agrawal and Josh Gans, of a new book titled Power and Prediction, The Disruptive Economics of Artificial Intelligence, which will be coming out on November 15th. Avi, thanks for being with us today.
It's great to be here. Thank you.
So this book is kind of it's a continuation of a book you wrote earlier, and you sort of start off by saying, here's what we got wrong in the previous book, and here's how we see the future. So tell us about the evolution of the book and what it's about.
Let's start at the beginning. So in about 2012, Jay founded this organization called the Creative Destruction Lab, which was to help science-based startups scale. And in that very first year, we had a company called Atomwise that said it was using artificial intelligence for drug discovery. And put yourself back 10 years ago, that just seemed crazy. Okay. It was led by somebody who was a former doctoral student out of Jeff Hinton's lab, a few blocks down the road from our business school. And the technology seemed really cool. And over the next few years in our program, we saw first a trickle and then a flood of these AI startups to the point where we decided this is really interesting and we wanted to try to understand it. We'd spent our careers trying to understand the economic impact of the internet. And we decided it was time to start thinking about the next technology, which we believed was going to be artificial intelligence. And so we got our heads together, we ran conferences, and we wrote a book. And that book was called Prediction Machines. And the key point in the book was when people think about artificial intelligence, they might think about super intelligent robots, like the ones in science fiction that could do just about everything humans do. That's very interesting and may very well be possible someday. But that's not the reason we're talking about artificial intelligence. Well, not the reason we were talking about it in 2018, and certainly not the reason we're talking about it today in 2022, because a very particular technology, a branch of computational statistics, sounds a little less exciting than AI, but we argue is still transformative, called machine learning, has gotten much better. And so we should think about AI as prediction technology. And the book came out in 2018, and we thought this revolution was about to start. We thought the world was going to change quickly because these technologies seemed extraordinary. They could translate between languages. They could label pictures. It seemed like industrial transformation was just around the corner. It took a couple of years and we figured, it's because things aren't quite digital enough. We haven't figured it out. And then the pandemic hit and everything went digital. And we thought, okay, now the revolution is going to happen. And the months went by and we realized still not there. We've seen AI make a little difference, but we hadn't seen it transform very many industries. And that got us to thinking more deeply about what technological change looks like and why a technology that we can see on the other side, how transformative it can be for industry, might not have had an impact yet and what the barriers to that might be. To do that, we dug into the history of technology and we looked at what happened with electricity, because lots of people are saying that AI is the new electricity. So if you were paying attention in 2018, we found at least a half a dozen articles and more quotes from leading thinkers, including the CEO of Google, saying AI is the new electricity. And that seemed fantastic. And from our Prediction Machines 2018 point of view, oh yeah, of course it's the new electricity. That's transformative. But then we remembered our history of electricity and realized it was a little less exciting than we thought. What do I mean by that? It was clear in the 1880s that electricity was going to be a big deal, but it wasn't until the 1920s that the median household and the median factory were electrified. It took 40 years for the average American to feel the impact at scale from electricity. Warren Devine Jr. and Paul David and some other economic historians dug into this. And the reason was because electricity wasn't just cheap power, but it allowed you to do things differently. So the first factories that used electricity just took out their old steam engine and put in electricity. And so what that did is it saved a little bit of time on power. So the factories, if you imagine the factories in the 1880s, they were organized around the power source. Why? Because the further away a machine is from the power source, the more energy gets dissipated. And so you organize your production to be so that the machines are as close to the power source as possible. The first factories that used electricity just took out the steam engine, put an electric motor, and changed nothing else. It was a point solution to their existing systems. And it helped productivity a little bit, but it didn't transform anything. And then over the next 40 years, people started to realize that electricity wasn't just cheap power, but it allowed you to decouple the power source from the machines. And once you could decouple the power source from the machines, you could organize your factory differently. So that instead of putting your machines as close to the power source as possible, you could lay out your machines horizontally over a big space where inputs go in one end and outputs come out the other. And it was only then that we saw the massive productivity boost from electrification, from electricity into factories that led to widespread adoption. So we think we're at the 1880s equivalent in artificial intelligence. We can see the long-term impact and the potential of the technology of prediction machines, but it hasn't come to pass yet. So what this book is about is thinking through, first, recognizing that while the technology has potential, we need to invent a whole bunch of processes in order to make it transform the way we live and the way we work. And so the book is about navigating what we call the between times. These times after we recognize the potential of the technology, but before we can see that potential come to pass.
One of the most interesting parts of the book, or parts of the book, I guess, because it runs throughout, is the theme of how rules, and I would say sort of just broader institutions, affect this. You call it, we say rules are glue. And there's a whole host of rules and institutions and incentives that can prevent this from happening, from getting this sort of systemic change. So I guess, sort of two questions about that. First, discuss those barriers. And also, you seem pretty confident that AI will overcome those barriers. So why is that?
So just trying to think through which part to go through first. Okay. So there are lots of people who want to slow down the progress of technology. They tend to be the people who are doing pretty well right now, given the state of technology, and not really excited to have disruption. And so large incumbents might be worried. People who benefit from existing systems might be worried. And so they're going to push back on regulation. Okay. So there are all these rules in place that are designed for an old system that inhibit the adoption of technology. So just as an example, in the summer of 2020, Jay, Joshua, and I, along with a political scientist, an epidemiologist, and an engineer who actually knew how to do things, the rest of us were academics, had this idea to help Canadian workplaces open back up. And Joshua wrote a book in the spring of 2020 that pointed out that for most people, COVID wasn't a health problem. For most people, it was an information problem. What do we mean by that? In the summer of 2020, for example, about 1 in 1,000 Americans had COVID. For them, it was a health problem. For everybody else, it was an information problem. If we knew who had COVID, we'd keep them home and the rest of us could go about our business. Now, if it's an information problem, there is a tool that should work really well for that. That's a prediction machine, right? Prediction is the process of filling in missing information. And so we should be able to find a prediction machine, an AI, that can fill in that missing information. And so we set about trying to find the prediction tool that could help people identify whether they had COVID before they went into work. Okay. We first went through a bunch of AI tools and it turned out none of them worked. Okay, fine. Went through a handful of others. We saw, articles about dogs sniffing people at the door to figure out if and they're like, that's not really practical. Eventually, by September 2020, we realized the rapid test, which is now familiar to everybody, was the best prediction tool for figuring out if somebody was infectious before they went into work. And so we had this idea of we're going to use rapid testing to allow workplaces to open up. And in Canada, many workplaces, even in the winter of 2021, were still closed. So we had the prediction machine. It wasn't an AI, but we had the prediction machine. By September 2020, it was pretty clear. It worked reasonably well, and it could solve a big problem. But they were illegal to use in Canada at first. And then once they became legal to use, it had to be done by a healthcare professional. And it had to be one of those brain ticklers that went way up into the nose. Okay. No one was going to submit to that twice a week for work. That just wasn't practical. And no workplaces would want to be hiring doctors to do that or nurses to do that. Over time, the regulations started to loosen up. But the biggest barrier to widespread adoption of this technology was not the prediction. Actually, the prediction tool in this case was the easy part. It took us about a year to work through mostly regulatory barriers. There's some other barriers too around organizations, like no one wants to get tested if they're sick, if they don't get sick pay. And so there are a handful of other pieces too that needed to come along. And eventually most of those were adjusted or balanced as public health learned more about how rapid testing worked. Okay. So like our experience there was very much, sometimes the prediction is the easy part, but that doesn't mean that the problem is solved, because you need to overcome these regulatory barriers in order to use the predictions effectively. Now, that was your first part of your question. The second part of your question is, why am I so optimistic? Okay. I'm optimistic for two reasons. Okay. But they're not really optimistic reasons. Okay. So I'm optimistic about overcoming the regulatory barriers, but why? The first reason has to do with the fact that I think our current systems are pretty bad in many ways. And so a lot of the talk about AI, for example, and the resistance to AI has to do with discrimination and bias. Okay. And there are very good reasons to worry that compared to a perfect benchmark, that machine learning tools, that AIs discriminate, say in credit scoring and in hiring and other places. Okay. So we should worry. But why do they discriminate? They discriminate typically because they're mimicking human processes. And we humans discriminate. So the reason I'm optimistic eventually we'll move to AI on many of these processes isn't because I think AI is so great. It's because I think we humans are pretty awful. Okay. And so because we're so bad at these kinds of things, and because many of our processes discriminate so much, it's going to be hard to ignore how good the machines are. Okay. And so I'm pessimistic that we can fix humans on discrimination. And hence I'm optimistic that the machines can do better, at least assuming they're run by some well-intentioned humans.
I totally agree with you about the human part, because we have thousands of years of history showing how awful humans are and how discriminatory and biased we can be. But I'm not sure I'm as optimistic as you are about the ability of a better technology being able to overcome that. I'm not sure whether the COVID example is a pessimistic, supports the pessimistic or optimistic view. And the same with, you have an example of this amazing algorithm in Flint, Michigan for replacing pipes. And that has elements of the positive and negative too. So, and also, one of the things I think that helps new entrants in anything succeed on a large scale is when the incumbents don't see it coming. But kind of everybody's seeing this coming, or they think they are. So, I guess maybe, I don't know what to do with that.
On this piece, okay. So one thing that machine learning does is it decouples the prediction from the rest of the decision. Okay, so you actually know what the prediction is, and then you can make the decision based on it. And the Flint, Michigan example is these two professors from the University of Michigan developed a prediction tool to identify which houses likely had lead pipes coming into them. And so which people were likely to be drinking toxic water. Okay. Now, if you remember, a few years ago, there was a water crisis in Flint because there was so much lead going into the water. And so they wanted to start replacing the pipes. And these professors figured out a way to predict which houses likely had lead pipes, and their algorithm was really good. It's about 80% accurate. Okay. And the city started to deploy it. And the results on the surface seemed fantastic. But a whole bunch of people in Flint, Michigan started complaining to their politicians, saying, hey, how come someone else's pipes got dug up, but not mine? That doesn't seem fair. I want to know for sure if my pipes are lead or not. And so the politicians overruled the professor's algorithm and said, from now on, we're going to do something fair. And what does fair mean? It means we're going to go street by street throughout Flint, Michigan. They were a little bit ambiguous about who got first, but if you look at the map, it looks like the powerful politicians had the people who vote for them go first. But there's some ambiguity there. But whatever, street by street to make sure it's a fair process. And the accuracy rate, so instead of 80% of the pipes they dug up actually having lead, it dropped to about 20%. So that's the bad story. That's the pessimistic part. But because the prediction was decoupled from the decision, there was clear what ground truth was. Okay. And it was clear that what the politicians were doing, once they got rid of that University of Michigan algorithm, was worse. Okay. And once it was clear that it was worse, people from the city effectively sued and eventually won a court case where a judge ruled that the city had to follow these predictions, had to follow what the algorithm said. And the success rate jumped right back up to 70%. And so it's pessimistic because, hey, the incumbents, they're going to fight for their own power. But it's optimistic because there's only so much. Once it's so clear that you're making the wrong decision, and here's why I'm optimistic on discrimination. Once it's so clear you're making the wrong decision, it's going to be hard to push back and say, no, we really do need to ignore the algorithm and discriminate just like we used to. Just like in the lead case, we really need to ignore the algorithm and allow lots and lots of children in the city of Flint, Michigan to be drinking toxic water. It's an argument that doesn't fly morally once you have, in that case, the good prediction.
So there, in that case, you have very clear outcomes that you can measure. But in lots of things, you don't. And so somebody will have to define a threshold level. And then, we already see this backlash against people just generally seem to not like algorithms. And this seems like a time in history when society is uniquely unable to deal with ambiguity and uncertainty. And, probabilities, I'm not sure, sit well with it. So is it possible? So I guess, first of all, you just say that I'm wrong, and it will be obvious in almost any cases, and that we will be able to deal with it in a policy sense, and we will be able to set thresholds. But would we separate policy from, business settings where they are more likely to have clear-cut objective measures?
Okay.
Sorry, that's a lot of stuff in one question.
Yeah. So I said I'm optimistic that we could overcome the regulatory barriers because I'm pessimistic about two things. So the first thing I'm pessimistic about is human decision making. We've talked about that. The other thing I'm pessimistic about in some sense is geopolitics and competition between countries. And so to the extent that these technologies enhance productivity and generate wealth, never mind the national security stuff, that's not my expertise, then there are reasons for regulatory bodies to not put the brakes on too much. Unless we have a global agreement that we don't want to use AIs for productivity enhancing aspects of work, then geopolitical pressures are likely to, I don't want to be a little careful in my language here, but the geopolitical pressures make me a little more optimistic about the adoption of the technology, though, as I said, not so optimistic about the direction of the world.
Let's all be a little less careful. So are you saying that we're worried that if we put the brakes on AI, then China won't? And that would put us at a disadvantage, and that will cause politicians to not want to put the brakes on? More or less?
Yes, that's one example. Well, it's not the only example because it's not the only other country, but yes. If we put the brakes on and others don't, then others will be ahead.
Do you see evidence of that?
Now, we want to be a little careful here, which is that there's a place, that's not to say the optimal is no regulation. I think this is actually an important caveat, which is clearly even for adoption of the technology, we want some regulation. We want people to trust it, right? So even something as simple as the elevator, you probably don't think about your elevator when you go in and out of the elevator. But when elevators first started being used for humans and not for freight, they were pretty terrifying. Or at least they seemed pretty terrifying. And so first, the engineers did all sorts of things to show that the elevators worked. But there was a regulatory system put in place. And to be honest, that regulatory system still exists today with elevator inspections to make sure that your elevators are safe. And that system is part of the reason why when we walk into an elevator, we don't even think about it. With AI, it's not to say we want no regulation, because we clearly want to think through what could go wrong. And we clearly want some regulation to ensure that people trust the systems, to your earlier point. So it's not about no regulation. It's trying to figure out how can we find that sweet spot where the regulation keeps people safe while also encouraging use of the technology.
Do you have thoughts on where we start with that? Lots of legislation is just very crude, but so what's the right way to start thinking about it? Is it, criminal justice issues? Is it sort of case by case? Where do we begin?
So I think the starting point is to move away from the idea that machines are making decisions. Mm-hmm. Okay. So when we talk about artificial intelligence, maybe because we've called it artificial intelligence instead of prediction machines, we have this idea that machines are actually deciding stuff. And to somebody who's not thinking about what's going on behind the scenes, it might seem like machines are deciding stuff, but machines don't decide things. Humans decide things, and underlying, at least as long as we're dealing with prediction machines, not artificial general intelligence, like it's a tool where the machine provides a prediction. The human decides which predictions to make and what to do with those predictions once you have them. So what machine learning does, through this decoupling of the prediction from the rest of the decision, is it can change who makes the decision. It can change the time and place of a decision, but it doesn't change the fact that a human or team of humans is responsible. So, for example, I don't know if you remember a few years ago, there was this story that Amazon was automatically firing people from their warehouses. Okay. There were all sorts of things in that story that weren't true. Like even the process as described wasn't quite what was happening. But even if we take those facts as given, even if we say, yes, there's this company that has a whole bunch of warehouses around the world, and it used to be the HR decisions at the warehouse were decided by a manager who worked in the warehouse. And instead, what somebody at headquarters decided was to build a prediction tool to measure productivity of each worker in each warehouse. And then at the end of the day, maybe even as the article might just, some of these articles describe it, at the end of every day, there's a score. And if you, the worker, fall below that score, you get an email saying you're fired. Okay. Even in that extreme scenario, it's not a machine making that decision. It's somebody at headquarters who decided they didn't trust the managers in the warehouses, who built their own tool to measure performance, and then decided what the right threshold was to send the notice that somebody lost their job. Okay. So again, to be clear, that's not what happened. It's how it was reported. But even in the way it was reported, it wasn't about a machine deciding. It was about somebody at headquarters figuring out how to massively scale their power, using this decoupling of the prediction from judgment to take power away from managers in warehouses and move it into their own purview in headquarters.
Well, would that have been actually, is it always the case that that's a better outcome? I mean, so then, it's still a person's decision, but you have one person's decision overriding lots and lots of people's decision.
There's lots of reasons to think it's no. Well, probably the reason why that article was largely fiction is because the company didn't think it would be an improvement.
Right.
So 100% agree with you. So the point of that story is just to recognize that any regulatory process that's focused on the AI we have today, not the AI we're going to have in 50 years. Because once we're thinking about machines that, artificial general intelligences that can do just about everything humans do, then it's just a different economics. And I haven't thought deeply about that, but some philosophers and political scientists have. But as long as we're thinking about the technologies we have today and in the short-term future, 5-10 years down the road or more, we need to recognize that there's no such thing as a machine decision. There is a human responsible. And so the starting point should always be understanding and allocating that responsibility. Then once we have responsibility, we can think through where do we want to do things through incentives? Where do we want to do things through criminal law? Where do we want to do things through tort law and elsewhere? And that's for, but the starting point should be, look, someone's making decisions. And if something goes wrong, there's responsibility for that human or team of humans.
So the machines are providing new, presumably more accurate inputs into a decision-making process.
Exactly.
Do you think we'll see lots of incidents where an AI takes in all the available information and gives you predictions that are more accurate than the ones you could make, but it bumps up against cases where people are known to not be rational? I mean, you talk about in the book that we know that humans aren't rational, even though we often assume that, and there's behavioral economists love talking about all the ways that people are irrational. What happens when an AI gives you information that conflicts with what people just feel is right?
So let's go to a specific example.
Mm-hmm.
Okay, let's think about an AI giving a doctor information that the doctor feels is wrong.
Good.
Okay.
Yeah.
So if you talk to doctors, they tend to say when they feel the AI is wrong, they overrule it and things are better than they otherwise would have been. For the most part, the studies that have looked at data when doctors overrule algorithms, whether it's AI-based algorithms or others, is on average, that's not good for the patients. Okay? Yeah, sometimes sometimes the doctor gets lucky, or there are some doctors who have some intuitive sense of where the machine fails. But for the most part, when we see humans in medicine overruling machines, once the machine process has actually passed some rigorous testing that it's good enough to be deployed, it's not so good for the patients. Okay, so then the question is, do we trust that human feel, or should we focus on the machine, or do we need to invent new processes to figure out how the machines and humans can work together? And I would argue that it's very much in that third category. Okay, and so one of the themes of the book generally is, for electricity, it took 40 years to figure out these new system solutions that would enable us to use the technology safely and effectively and productively. And part of new system solutions for AI is going to involve new decision-making processes, new job titles, new roles, new meanings for medicine, what it means to be a doctor. And we haven't figured that out yet. So we know that machines on average might be better, but that might not be enough for the humans who make decisions to trust them. We are, on the regulatory side, there's people pushing for models of explainability to enhance trust so that people can understand the reason behind the predictions. I think in some contexts that makes sense. In many contexts, that's a little misguided because I worry that the explainability is largely a fiction. Mm-hmm. So to the extent that a machine learning model has thousands and thousands of parameters, any explanation that the machine is going to give to a human decision maker is probably going to focus on 2 or 3 main factors. And some fraction of the time, it's going to be those 2 or 3 main factors, but it might be thousands of others, and that's not going to come off cross in explainability. In medicine, right, if we're going to test a new drug, every single drug, maybe not every single, but pretty much every drug that hits stage 3 clinical trials has an explainable reason why it should work. And yet lots of drugs fail stage 3 clinical trials because we just don't know that much about how the human body works. This is Ziad Obermeyer, who's a professor in the public health school and a doctor at Berkeley, and also an economist, has said, for machine learning tools, we should have the same threshold that we do for drugs. We don't need to explain them. We just need to show in practice that they work and they save lives. And if that's the case, who cares if we really understand why? And I think, to me, that's a big part of the regulatory transformation and the new systems to understand what kinds of changes engender trust that are real, as opposed to creating a false trust through, in this case, explainability.
So I think puzzle I wondered about on that line of thought. You mentioned the Solo quote that automation isn't showing up in the productivity statistics, and that it's mind-boggling that the internet wouldn't show up in our productivity statistics. Are we going to be able to tell if AI is improving our quality of life? And maybe it is non-market goods, not monetary, but how do you square that circle?
No, that's a great question. So the Solo quote was from 1987, talking about computers from the 60s and 70s and 80s. They hadn't shown up yet. And then in the mid-90s, we started to see the impact of computers and their productivity stats. It lasted about a decade. And there's an argument that the internet started to show up toward the end of that and a little bit later. We haven't seen AI yet. Maybe we'll, judging from the history of other technologies, it's not that we'll never see it. It's just that it takes an awfully long time to figure out these new processes. And so some technologies, you see the boost right away. It happens. It's like a step function boost, and then it flattens out again. For what we call general purpose technologies, after a paper by Bresnan and Trachtenberg, they have their impact through this positive feedback loop of innovations in producing and using industries. And that feedback loop just takes time to play out. So we did see computing in the productivity stats. It just took 40 years. We did see the internet in the productivity stats. It just took something like 25 years. When we see AI in the productivity stats, one version is if we just wait, it's going to take another 25 to 40 years. My hope is that by understanding the history of technology and the need for particular kinds of co-invention, that we can accelerate that process and make it, I don't know if it's 5 years or 10 years or something a little bit longer than that, but not 40 years.
I think, remembering the 40-year issue is important, although it's frustrating that none of us will be around to run the regressions to measure it. But going back to that point, and the point Sarah raised about the measuring productivity, you talk in the book about the radiologist issue. That one of the common predictions early on was that radiologists would become obsolete because AIs are so good at recognizing patterns. But that didn't happen. Is this an example of that systems take a long time to change? Is it an example of the, whatever institutions protect doctors keeping AIs from succeeding? Or, is this just a function of time? So what explains this, where it's this perfect thing that AI should be able to do?
So I think there's been 3 things that haven't happened with radiology. Okay. The first one may be the most important, which is we still don't have an AI that can do all the predictions in images that radiologists do. Okay. So we haven't been able to create a really machine radiologist who can do all the non-interventional things that that radiologists do. Okay, so that's barrier number one. Now, in particular context we have, and why aren't we using those at scale? Okay, so the technological reason, there is a regulatory reason. And I'm actually quite optimistic about the regulatory reason, which is that approving health technology, like medical technologies, takes 5 to 10 years. Okay, it was obvious 6 years ago that we had some hope and that things were going to change. And so we should expect some changes over the next, say, 5 years or so. So that's number two. Number three is the one you alluded to, which is people tend not to fire themselves.